Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhiyatin Sofia binti Syarul Anwar and I'm from Group 3A and I'm going to present about operating system security for CSC207. Operating system security is essential in safeguarding memory, files and user authentication. It is primarily achieved through the use of firewalls, antivirus software, frequent operating system updates, and enforcement of secure access through least privilege and user restriction. Consistent protection ensures that the system meets standard security requirements and has the necessary functionality to enforce security practices. Overall, operating system security is essential for maintaining the integrity and safety of a system. Protection is an important aspect of security that restricts user access to files and control system access. It ensures that users or processes have permission, ensuring that CPU, memory regions, and other resources are accessible to authorized users and programs. Protection is essential for operating system with multiple programs as it prevents untrustworthy users from sharing memory, directory, and logical and physical namespace. It is essential to implement an identification and enforcement mechanism for controls, ensuring that every running program in a system only uses authorized resources. Besides that, I will explain the definition for security. Security is a crucial aspect of a system operation, ensuring that it is protected from unauthorized access, manipulation, or inconsistent use of computer resources. This includes data stored in disks, CPUs, RAM, and other components. The security system authentication procedure is emphasized to protect the system's physical resources and data accuracy. It is a technique that guards user data and programs from disruption caused by external parties or entities. An organization's main duty is to execute security precautions to prevent outside users from gaining unwanted access to company data. Protection is a vital function in computer systems, implementing policies that dictate resource usage. System administrators set rules to protect files and applications, while programmers create protection strategies to protect against intrusion. These policies are subject to change, and both the operating system designer and app programmer are responsible for them. Protection objectives include ensuring the safe use of CPU, memory, software, and the operating system. Programmers create protection policies which are implemented by management or defined by the program itself. These guidelines are subject to change at any time. In conclusion, protection aims to implement policies defining computer system resource usage, with system administrators defining rules and programmers creating strategies to protect against intrusion. System security is not the designer's responsibility. Next, I will explain the definition for user authentication. User authentication is a human-to-machine process that confirms a user's identity during network context, preventing unauthorized access to a network or computing resource. It ensures only authorized users can access the system, preventing damage, data theft, and other issues. Unlike machine authentication, which requires human input, user authentication is essential for most human-computer interaction. It grants authorization for both wired and wireless networks, enabling access to network and internet-connected systems and resources. Password authentication is a crucial process used to verify a user's identity by providing a confidential code, which is then validated against a stored database to confirm their access to a digital system. Next, I will explain about password weaknesses characteristic. First, using the same password as before. Second, the names of close friends or relatives. Third, your appellation. Fourth, dictionary terms. 5. Typical names. 6. Entering your login code again. And lastly, swipes and patterns on the keyboard. And these are the example. These are some ways to overcome password unprotected. First, create unique, secure passwords using capital and lowercase letters, digits, and special characters. Avoid popular or easy to guess words, and ensure each account has its own unique password. Second, implement a comprehensive password policy for your company, outlining the length, complexity, and expiration specification, and educating staff on the importance of strong passwords. Third, utilize password management software to securely store and manage business credentials, automatically filling in login or information, creating secure passwords, and storing them in an encrypted database. Lastly, multi-factor authentication, MFA, is a practical security measure that requires users to provide an additional piece of information, such as a one-time password, in addition to their password. Token-based authentication creates encrypted security tokens for users to access restricted resources without re-entering the account and password. This method enhances user experience and security by allowing access to programs and resources without requiring continuous identity verification. Token-based authentication involves 5 steps: request, verification, submission of the token, storage, and expiry. The user logs in, sends an access request, then server confirms login details, and the user receives a secure signed token. The token is stored for future website visits and is decoded and validated when a match is found. There are 3 types of tokens: connected token, disconnected token, and contactless token. To access a system, a token and the user system must be physically connected. An example is a YubiKey like smart card or fob. When inserted into a reader, the reader sends authentication data to the computer system. Connected tokens are hardware devices that need to be physically placed into a computer or device sensor. Common examples include one-time password or OTP and FIDO2 security keys. Examples include smart card scanned by a card reader and hardware security modules for cryptographic activities connected to a server. A disconnected token is a two-factor authentication device that is created by computers over the internet and long distance with servers. It includes OAuth protocols and an OTP tool that provides verification requirements via text or email. Examples of disconnected tokens include time-based one-time password or TOTP, generated apps for mobile devices used with two-factor authentication, and display cards with a grid of numbers on which users enter a code for each login. Bluetooth token and keyless entry system operate by establishing a wireless connection with the system. allowing users to access or restrict resources based on their link. These devices, produced by a hardware device, do not require physical insertion. When the device is within range of a server or resource, the token is sent wirelessly. Bluetooth tokens are an example of this technology. Examples include wearable technology with near-field communication token for contactless payment and biometric tokens that allow access without physical touch through facial or fingerprint recognition.
Next is biometrics. Biometric authentication is a cybersecurity method that uses a person's unique biological characteristics such as voice, fingerprints, retinas, and facial features to verify their identity. These details are stored by biometric system, making it more secure than traditional multi-factor authentication method.
There are two biometrics characteristics, which are physiological and behavioral. Physiological biometrics is the analysis of a person's physical traits, such as iris, palm, or fingerprint, which are usually fixed and unchanging as they age. This characteristic can be used to identify, confirm, or authenticate an individual online, such as signing into an online banking system. Other uses include face recognition and physical access control, typically through CCTV, and these are the example of physiological biometrics. Behavioral biometrics is a method used by organizations to detect and quantify human behavior patterns, such as mouse or typing routines. These techniques analyze cognitive and digital activity patterns when users interact with digital platforms. If this pattern deviates from expectation, it may indicate fraud, leading to step-out authentication or account suspension. This background security measure helps organizations maintain secure and prevent potential breaches. However, it's important to note that this method may not always be observed firsthand, and these are the example of behavioral biometrics.
Memory protection is crucial in modern operating systems to prevent unauthorized application access to RAM, allowing multiple programs to execute simultaneously without affecting their individual storage spaces. The main objective of memory protection is to prevent unauthorized access to RAM, which is terminated by the operating system. Memory management devices, such as equipment memory backups (MMUs), are used to link physical locations in memory to digital addresses used by a program. MMUs ensure that only authorized files are accessed and translate fictitious addresses into genuine ones. Memory virtualization is a common technique used by modern operating systems to achieve memory security, allowing each program to run in its own virtual address space, which is mapped to physical memory via the MMU. This allows multiple programs to operate simultaneously, sharing the same physical storage space, but each having its own virtual address space.
Next, what is the importance of memory protection? Memory protection prevents software from consuming large amounts of memory, potentially causing harm to existing programs or data loss, and blocks processes from accessing unallocated memory in the operating system. It also helps detect malicious apps that could compromise the system processes.
Next, I will explain about buffer overflow. Buffer overflow is a software security flaw that allows hackers to gain unauthorized access to company networks. Despite being well known, it is prevalent due to its various causes and the need to prone errors to prevent it. Buffers, which are consecutive portions of computer memory that temporarily store data, are the subject of this flaw. When the buffer's data volume exceeds its storage limit, excess data overflows onto nearby memory regions, corrupting or overwriting the information.
Next, I will explain about buffer overflow protection and how to stop buffer overflow. Programmers must correctly check input and make sure the buffers are large enough to retain the intended data in order to prevent buffer overflows. Furthermore, buffer overflow attacks can be thwarted by security mechanisms like address space layout randomization and data execution prevention. Let's examine a couple strategies to stop buffer overflow. First, it is more difficult for attackers to carry out a successful buffer overflow attack when an OS runtime protection is used. The technique known as address space layout randomization or ASLR aids in positioning crucial process areas. It comprises the locations of the libraries, stack, and heap. Third, by ensuring the regions are either designated or executable or not, the EP guards against attackers using buffer overflows to execute instructions within to an area. Next, an organized exception handling prevents attacks via stack-based buffer overflows by overwriting protection. Patching devices guarantees that buffer overflow vulnerabilities will be found. It is imperative to implement safety precautions during the interim period between the creation and deployment of the security patch. A buffer overflow attack is less likely when the principles of least privilege are followed because users and programs are granted to authorization that need to carry out their employment or other critical duties. 6. Choose a language like Python or Java that prohibits buffer overflow. Next, to make sure that user supplied data does not go above the buffer's RAM allotted, employ input validation and sanitization. To stop overflows, use safe coding technique like verifying array limits. Employ security measures such as firewalls and security tools to keep an eye out for and stop buffer overflows attack. Update software and system with the newest security patches and upgrades to stop known vulnerabilities from being exploited. And lastly, inform staff members and users about buffer overflow attack threats and the value of adhering to security best practices.
And next, I will explain about data execution prevention, or called as DEP. Windows has a feature called data execution prevention that prevents executable code from launching from unintentional locations. DEP designates specific memory location for data only, preventing executable code or applications from operating from those areas. This aims to make it harder for attackers to operate malware from memory regions that typically hold data through buffer overflows or other methods. Kernel patch protection, also known as kernel patching, is a feature in x64-based Windows operating system that prevents code and key structure from being altered by unknown application or data, thereby enhancing the operating system dependability, speed, and resilience. In conclusion, Operating systems are crucial for safeguarding digital assets, user privacy, and system integrity. They use measures like access control, encryption, authentication mechanisms, and regular updates to provide a secure environment. Features like firewall, antivirus software, and intrusion detection system are designed to protect against threats. Regular security audits, patching, and best practices are essential to maintaining the resilient defense against potential breaches. Collaboration between developers, security professionals, and end users is essential for creating a layered security approach. In the dynamic cybersecurity landscape, continuous improvement of security protocols and proactive measures are vital. Operating systems are the foundation of digital interactions and directly influence the trustworthiness of computer environment. Therefore, a comprehensive and adaptive security strategy is essential to navigate the ever-changing threat landscape. That's all from me. Thank you.